Alright guys, so we're going to be continuing our work on section 5.2. We're going to look at when do we need to use absolute value. The only time we're going to have to use absolute value is when we are working with a variable. If we have a constant, it does not matter. It's only when we have a variable. And the reason is because if we're taking an even root, we know that the answer has to be positive. For example, if I take the square root of 4, that's 2. The square root of negative 4, I can't even do, it's imaginary. The square root of 27, that's 3. I'm sorry, cube root of 27, that's 3. The cube root of negative 27, that's negative 3. So this is okay. If I have an odd root, it's okay if I have a positive or negative answer. I can get either one. But if I have an even root, the only answer I can get is positive. This will never happen. It's not negative 2. There's no answer to that. That's imaginary. So we are going to have to use absolute value when we're simplifying roots with variables if it's an even numbered root. Very important there. Let's come down here and do some problems. If I'm doing the fourth root of x to the fourth, that's just x. But think about this. What if x had been negative 2? Negative 2 to the fourth would have been 16. What's the fourth root of 16? Positive 2. Well, we're saying that this answer should be x, but it's not because x was negative 2 to start with. So the answer is not x. The answer is positive 2. So the answer is the absolute value of x. So this is something we are going to have to now watch for. Watch this one though. If I do this problem, this can be thought of as the fourth root of x to the fourth times x to the fourth. So the fourth root of x to the fourth is x, and the fourth root of x to the fourth is x, and so therefore the answer is x squared. In this case, though, I don't have to use absolute value, because even if x had been a negative number, and I take the fourth root, that's going to be positive, right? But it won't x squared always be positive anyway? So it would be redundant to use absolute value. I know this answer is positive, so I don't have to use it. Alright, what about this? The cube root of x to the third. Well, that's just x. Do we need absolute value? Well, let's think about an example. Let's say x again is negative 2. Negative 2 to the third is going to be negative 8. The cube root of negative 8 is negative 2. Is the answer the same as what x was? Yeah, it's negative 2. This should not have absolute value with it. It's allowed to be negative. It's fine. Alright, let's look at this one. The cube root of x to the sixth. Alright, so we've got the cube root, this would be x to the third times x to the third. Cube root of x to the third is x. Cube root of x to the third is x. This answer is x squared. Do we need absolute value? No. The reason why is this is a cube root. It's an odd root. I don't need absolute value no matter what. But my answer is x squared. It's even going to be positive again, so it does not matter. Alright, let's look at this. Now we're doing a sixth root. So the best way to think of this is x to the 18th is x to the 6th times x to the 6th times x to the 6th. 6 plus 6 plus 6, bases alike, add the exponents, that's 18. This is going to be x, this is going to be x, this is going to be x. So this is x cubed. What do you think? Do we need absolute value? Yes or no? Yes, we do. The reason we need absolute value is because x could have been negative since it's getting raised to an even power. A negative raised to an even power is going to be a positive number. And then when I take the sixth root of it, it's going to be a positive answer. But x could have been negative at the beginning, but our solution can only be positive at the end. So that's why we have to use absolute value. Now, if you go back up here, I want you to think about what is meant by even, odd rule. Look at this. Even, odd. Even. So that did not apply. Odd. That's not even, odd. Look again at this one. even, odd, even. That's not going even, even, odd. Look at this one. Even, odd. I am not going to be using that rule. I would rather you understand this instead of trying to memorize that. Understanding that at the beginning this x could have been negative, it's raised to an even power, it turns positive, taking the sixth root, it has to be a positive answer, but this could be negative because it could have been negative at the beginning, but we know that the sixth root of any positive number has to be positive. That's why we need absolute value. Alright, so that's absolute value. Let's look at this one. Alright, so we're doing the cube root of negative 27. What is that? Negative 3. To do this quickly, I can do d to the 12th over the root. That's the quick way to do that. That's going to be negative 3 d to the 4th. What do you think? Do I need absolute value? No. I'm taking a cube root. It's okay if d is positive or negative at the beginning, and d is allowed to be positive or negative at the end. So it doesn't matter. I don't need it. All right, let's try this one now. The fourth root of 16. The fourth root of 16 is 2. The fourth root of x to the 4th is x. The fourth root of y to the 12th is y to the 3rd. The fourth root of 81 is 3. The fourth root of z to the 8th is z squared. Now, I need to see if I need some absolute value here. I had this x could be negative because it's being raised to the 4th power, and that would turn positive. But now, at the end, I just have x to the 1st. Well, that could be negative, but the answer can't be negative because it turned positive here. So this is that whole even, odd. I need it around that. So look at this one. Y could have been negative here, but then when it went to the 12th, it turned positive, and then I took the 4th root, which would have to be a positive number. So I have to use absolute value there. I'm never going to have to use absolute value here because it's getting squared. So even if z had been negative at the beginning, and it's negative here, if it gets squared, it's going to be positive. And so therefore, this is my solution. All right, let's come down here. We're doing the fourth root. Let's check these out. Let's make this as one whole expression. Let's see, this would be x cubed times x is x to the 4th. And then I also have 81. All right. Now, here's something else we're going to throw in. When we have a fraction, I need to look back here at this denominator. Because I have x's down here in the denominator, I know x is not allowed to be 0. Okay? It can't be 0, because then I would be dividing by 0. So I'm keeping that in mind. If I still have x's in the denominator at the end, then I would still know that x can't be 0. So let's see what happens on this one. We've got the fourth root of 16. Actually, I'm going to work from the inside. So I'm going to have 16 over 81. These bases are alike, so I can subtract my exponents and get 32. The fourth root of 16 is 2. Here I have 32 divided by 4 would be x to the 8th, and the fourth root of 81 is 3. And we think that's our answer. When I look at this, do I know that x can't be 0? I don't, do I? So when I look back here, the domain here was x cannot equal 0, but the domain here is not showing that. So therefore, I would have to say this is not going to work if x is 0. At the beginning, if x is 0, the function's undefined. But down here, if x is 0, the answer is 0. I would get two different answers. So I have to say this is equivalent to this as long as x is not 0. Okay? X cannot be 0. Otherwise, this one's undefined and this one would have an answer of 0. So when I look at this domain, I say x can't be 0. And I would not get the same solution down here, so I have to make that restriction. I want you to look back here for a minute. You might be thinking, yeah, well back here z can't be 0. That's true. This would be undefined if z is 0. But can you see how if 0 is our value for z here, this one would also be undefined? So therefore, I don't have to write this. Because if z is 0, this is undefined and this is undefined. I get the same answer. But that was not the case here. So that's why I need it. I like to jot that down at the very beginning. Anytime I have variables in the denominator, I'm looking at this. X can't be 0, y can't be 0, z can't be 0. None of those are allowed to be 0. I'm keeping that in mind. I have to make sure that that's true at the end too. Alright, let's take this one step at a time here. Alright, I've got 21. I've got x to the negative 3 halves. I'm going to take that to the bottom and make it positive. I've got 7 to the negative 1. I'm going to take that to the top to make it a positive exponent. I've taken care of this, I've taken care of that, and that. I've got radical y. Now because this has a rational exponent, I'm going to write this with a rational exponent. Y to the 1 half. Z I'm going to keep to the 5 halves. This x, I'm going to write it as x to the 1 half to keep my rational exponent. This is my root, this is my power, x to the 1 half. Okay, so I took care of the z, got that one. Okay, y to the negative 1 half. I'm going to make it positive, I'm going to take it to the top. And then z, that's just going to stay where it is. Alright, so now let's go. We're going to simplify. So 21 times 7, that's 147. Let's see what else we can do. We've got these y's are both have like bases, so I can add the exponents and get y to the first. I'm going to keep this like this for now. I've got an x to the 3 halves, x to the 1 half. I have like bases, add the exponents, that's x squared, and then I've got a z. Alright, so now we're going to finish this. So we got 147. We've got like bases, and we're dividing. What do we do when we're dividing and we have like bases? Subtract the exponents. So this is an exponent of 1. I'm going to think of 1 as 2 halves. It's higher here, so I'm going to subtract these exponents, and I'm going to keep it on the top. 3 halves, because it's higher here. Wherever it's higher, that's where it goes. I also have the y. And I have the x squared. That's not going to change. Alright, now they told us to write all these in radical form. So I'm going to have 147. Y stays where it is. Z is okay. I got to think that that was really the square root of z cubed. And z cubed is z squared times z. So the square root of z squared is z. That comes out. But that one has to stay in. Those are my z's, all over x squared. Now, two things I have to look at here. Absolute value. I got to go back to the beginning and figure it out. So, at the beginning, I had the square root of y here. So, I wouldn't have to worry about it. I would already know that y could not be a negative number. I would know that right there. So I don't really have to use absolute value there. Let's look at the z's though. Z is to the, I would be taking the square root and it'd be z to the 5th. If it's z to the 5th, I would, again, I would know z can't be negative there. Because z to the 5th would have given me, if it's negative, it would give me a negative number and I would know I can't take the square root. So I'm not going to have to use absolute value around the z. And x squared, because this is, x squared, I don't need absolute value because even if it was negative, it's going to turn positive. It doesn't even matter. I don't even have to look back at the beginning. Now, the other thing I have to look at are my restrictions. So x can't be 0. I can see still that x can't be 0. Y isn't allowed to be 0 at the beginning, but, well, now I can't see that. So I would have to say then, y cannot equal 0, And let's check out z. Nope, we can't see that z is not allowed to be 0. Here, z could be 0, because it's in the numerator and not the denominator. So I would also have to say z cannot be 0. And that would be our final answer. Alright, so a little bit more complicated stuff, but understanding it is very helpful. I want you guys just to try one here. What if I gave you the 4th root of x to the 6th over the cube root of z cubed? Try it on your own, and then I'm going to write the answer. So pause the video for just a minute and try that. And that's what you should get. I do not need to make a restriction. Z can't be 0 at the beginning, 0 can't be 0 at the end, so I don't have to make any restriction. The x did need absolute value because x could have been negative here. And that's it.